Hello everyone. Today we want to solve a limit question. It says that our x is approaching to 2 from left hand side. So on the numerator we have absolute value of this, and in the denominator we have that. So first of all, we should take care of the absolute value. We do not like to see absolute values in our functions, in our limits. We should basically take a look at the absolute value as the very first thing that we are going to do. So our x is approaching to 2 from the left hand side. So it means that our x is not equal to 2, but it is something like 1.9999, right? So it's a little bit less than 2. So our numerator is x to the power of 2 minus x minus 2. You can write it as x to the x minus 2 times x plus 1, right? You can write it as this. So if you plug in this amount of x, this part of the problem would have a negative value. Why? Because x minus 2, if your x is 1.999, would be less than 0. And this part of your question would be positive, right? So a negative value times a positive value would be a negative value, right? So what we are certain about is that this part of the question is negative. So whenever we have a negative value and we want to find the absolute value of it, it will be positive of that value. And whenever we have a positive value inside the absolute thing, what comes out is the 2 itself, is the positive 2 itself. But we know that inside the absolute value we have a negative value, so we should change negative to positive in here. So what we should do is that we initially had x to the power of 2 minus x minus 2 in the absolute value. We should change it to negative this, which equals negative x to the power of 2 plus x plus 2. The negative comes here, comes there, and also there. So this value is what comes out, the absolute value, right? So let's write down the question once again. We have limit of negative x to the power of 2 plus x plus 2 over 2x minus root x to the power of 2 plus 12. X approaches to 2 from the left hand side. Again, the first thing for limits is replacement. Replacing the x. Let's do it. So it will be minus x to the power of 2 plus x plus 2 over 2 times x minus root 2 to the power of 2 plus 12. So the upper part is going to be minus 4 plus 2 over 2 times 2 is 4 minus root 4 plus 12, which is 16. Root 16 is 4. So here it would be 0 over 0. Again, whenever we got 0 over 0, we have to use the L'Hopital rule. The L'Hopital rule says that you can apply derivative of the numerator and the denominator and find the answer at the value that the question has asked you about. Right? You can take a look at my second video which mainly talks about the L'Hopital thing. So let's find the derivative of the numerator first. We have derivative of negative x to the power of 2 plus x prime, or derivative of x plus 2 prime, over this guy in here. If you remember, we had some rules that one of them was derivative of u plus v, which is u prime plus v prime. In here, the u is 2x, and root x to the power of 2 plus 12 is the v. You can take a look at derivatives in 10 minutes video to find out what these rules are. And I have talked about 6 different rules that you will be able to solve plus 90% of derivative questions based on these 6 rules. So our u in here is 2x. So we have 2x prime, right? 2x is the u, 2x prime, minus the v is root x to the power of 2 plus 12. So it will be x to the power of 2 plus 12 prime. We had another rule, which is c times u to the power of n prime, it equals c times n times u prime times u to the power of n minus 1. The c and n are constant and u is a function. In here, we have exactly the same thing. Let me write it down in here. Minus x to the power of 2 prime minus 1 times x. So we have minus x to the power of 2 here. You can write it down as minus 1 times x to the power of 2. Then you can see that your c is negative 1, your u is the x, and the n is the 2 in here. So if you want to solve this derivative question, you will use this formula. The c is minus 1 times your n is number 2 times u prime, which is x prime in here, times u, which is x to the power of n, which is 2 minus 1. 2 minus 1. 2 minus 1 is 1. So it will be negative 2 times x prime is 1 times x. So it will be negative 2x, right? So it will be the answer for derivative of negative x to the power of 2 for this part of the question. Then we have x prime, or derivative of x, which is equal to 1, and the derivative of a constant value is 0. Then we get to here. Derivative of 2x. We can write down a power of 1 for the x. Doesn't make any problem. The formula that we had is this, right? So your c is 2, your x is u, and your n is 1. Again, we have the formula here. I'm gonna write it down. C times n. C times n is like 2 times 1 times u prime, or x prime, times, where did it go? My God. Times u to the power of n minus 1. U, or x to the power of n minus 1. X to the power of 1 minus 1. 1 minus 1 is 0, x to the power of 0 is 1, x prime is 1, so the answer is 2. Okay, so derivative of 2x is just number 2. So it will be 2. But what about this part? Root x to the power of 2 plus 12. If you take a look at the video that I mentioned too, the derivatives in 2 minutes, I have told you how to deal with these sorts of questions. So I do not like to see the root in the question of derivatives. I always change it to power. You can write it as this. Root is power 1 over 2. In our cheat sheet, we had this formula again. I can write 1 times this, it doesn't harm. So the c in here is 1. The u in here is all of this part, and the n is 1 over 2. So I want to find the derivative of this or derivative of this. So if we take a look at the formula, again it is n times c times u prime times u to the power of n minus 1. Let's have it here. N times c, n times c, 1 over 2 times 1 times u prime, or x to the power of 2 plus 12 prime, times u to the power of n minus 1, u to the power of n minus 1, which will be u to the power of n minus 1. So we have 1 over 2 times here, x to the power of 2 plus 12. We had this formula in our cheat sheet, which is u prime plus v prime. You can write it like your u is x to the power of 2 and your 12 is v. So you can write it as u prime plus v prime times here, x to the power of 2 plus 12 to the power of 1 over 2 minus 1. It is negative 1 over 2. Okay, let's go ahead. 12 prime, or the derivative of a constant value, is 0. Derivative of x to the power of 2, we found it out somewhere here. It was negative x to the power of 2, which was negative 2x. Right now it is positive, so it will be positive 2x. So we have 1 over 2 times 2x times x to the power of 2 plus 12, x to the power of 2 plus 12 to the power of negative 1 over 2, right? So this is going to be the answer for this part of the question. So let's write down what we have. So in here we had 1 minus 2x. In here we have 2. So 1 minus 2x over 2 minus the derivative of this, which we found out here. I'm going to write it down. The 2 and 1 over 2 cancels out, so we have minus x times x to the power of 2 plus 12 to the power of negative 1 over 2. So we want to find the limit at x approaches to 2 from the left hand side, right? And again, we use the L'Hopital rule, and we got to here. So right now we have to replace the 2. So we have 1 minus 2 times x over 2 over 2 minus x, which is 2 times x to the power of 2 or 2 to the power of 2 plus 12 to the power of negative 1 over 2. So the numerator is 1 minus 4, and the denominator is 2 minus 2 times 2 to the power of 2 is 4 plus 12 to the power of negative 1 over 2. The numerator is negative 3, and the denominator is 2 minus 2 times, so I have negative power. For the negative power, I can do 1 over, right? And again, I have 1 over 2 as the power. I can write it as the root of 4 plus 12. 4 plus 12 is 16. Root 16 would be 4. So it is minus 3, like negative 3, over 2 minus 2 times 1 over 4. 2 times 1 over 4 is 1 over 2, so it is negative 3 over 2 minus 1 over 2. 2 minus 1 over 2 is 3 over 2. So we have negative 3 over 3 over 2, which would be negative 6 over 3, and the answer is negative 2. That's the answer for the question, and if you have any other questions, please let me know in the comment part of the video, and I hope you enjoyed the video. Thank you.